continuing our discussion on uniform circular motion, we're going to look at motion of a four-wheeler on a flat curved road. So let us say we have a four-wheeler which is moving on a road. Let us say this is the road, and let us say we have a four-wheeler. I'll show it with the help of a simple block. Let us say this is a four-wheeler and these are the two wheels of the four-wheeler, right? And it is, let us say, moving in this particular direction and is taking a turn. As we said earlier, the road is a flat road. That means it does not have any banking. It's a flat road. This end and this end, both the ends are at the same level, and it is taking a turn along this path. Let us look at some dimensions. Let us say this is the center of gravity G of the vehicle, and let us say this height is h. Also, let us say the distance between the two wheels is 2x. This distance is 2x. Right. This vehicle is moving along this road and is taking a turn. Let us now look at the various forces which come into play. One force that comes into play is the weight mg of the vehicle, and this mg, for this mg we'll have normal reactions R1 and R2, right? R2. So these are the normal reactions for force mg. Apart from this, we'll also have frictional force coming into play. Let us say this is the direction of frictional force. Let us say this is F1. The F1 is the frictional force between the wheel, the first wheel and the road, and F2, right, is the frictional force between wheel 2 and the road. We will not worry about the magnitudes of F1 and F2. Both of them will be same and the direction will be same. Okay, let's move further. From this diagram we have two equations. mg is equal to R1 plus R2. The two normal reactions will balance the weight of the vehicle, and F1 plus F2. F1 plus F2, the frictional force that will be responsible for giving the centripetal force. So this will be equal to mv square upon r. The frictional force is what is causing, what is generating the centripetal force which allows this vehicle to take the turn. That will be equal to centripetal force mv square by r, where r is the radius of this turn. So this, if this is the direction, this is the curve along which the vehicle is taking a turn, then this can be considered as part of a circle, right? And let us say this is the center of the circle along which this is taking a turn, and this distance will be r. So F1 plus F2 is equal to mv square by r. Also from this I can write down mu r1 plus mu r2 is equal to mv square by r. That is because friction F is equal to mu r, right? So we have got two equations, equation 1 and